Alright, another in this series of videos, just merely pointing out, or through a question, a rhetorical kind of question, why can't this be the right answer versus the answer they've given us. So this subject is the two-slit experiment, the most famous experiment in quantum mechanics anyway, the origin of the whole wave theory, of the one they decided on anyway, the particle duality wave theory. It's a particle and a wave, but it's really a wave. That's what they're saying. Except for Feynman, who says, no, it's just weird and we just do math. We don't care why it happens. We just care what happens. And that's sort of part of the subject, is that they seem more interested in interpreting experiments than they seem interested in understanding experiments. So experiments provide information, and you can spend a lot of time just trying to figure out what the information is, exactly what it's doing. And you can apply all kinds of precision to understanding what actually happened in the experiment. Or you can spend a lot of time speculating about what it means. What you've drawn the simplest conclusions, or the vaguest, what you can see the easiest through the fog, without worrying about the details. So the two-slit experiment has details. The history has details. The fact that Newton had already done substantially all the necessary experiments and had already seen the pattern, and that they needed this guy called Young to show up 100 years later and do almost nothing, add no real information to what Newton had already discovered as a phenomenon. And yet they think that two slits make some sort of difference when it really doesn't. Newton obviously couldn't do some of the experiments, but he did a lot of optical experiments. Just didn't do these enough, I guess, to figure out certain rules, certain facts, and those facts are completely ignored in this whole conversation about what it means to put light through apertures. More specifically, I would argue what it means to put light next to surfaces. So the whole idea that these are called the surface experiments, the slit experiments, when they are more rationally called the surface experiments, because surfaces are what's causing the effect. You can put a single impediment in front of a light source and you will create a wave interference pattern. And there's no good reason for, there's no good explanation for why that's a fact. And mathematically, the single impediment's width will correlate to the distance between two surfaces in what is called a slit, or an opening. And the reason why there should be a correlation is because the only thing that's consistent between the single impediment and the single slit is the actual distance between the surfaces. In one case, the surfaces are facing out. In the other case, they're facing in, but it's exactly the same distance. And so those are facts that lead to an understanding of the experiments, and that's where I'm saying there's no conversation by physics about the facts regarding what the experiments produce. So in the case of the multi-slit, when you had 3 or 4 or 5 slits, you end up sending images to specific locations. That is, exactly what photons go in here are represented in each location. Now, there's no wave interference way you get that to happen, where there's this huge consistency, because in wave interference, the photon is neutralized in terms of there's no meaning to going right next to the slit or going right through the middle of the slit in terms of the manufacture of the interference pattern. So it doesn't really work as an explanation. I'll pause here for a moment. Alright, I'm back. Mostly. Part of me is. Trains have, been placed on other tracks, but so the idea is there's a whole bunch of details about these experiments and combining the experiments. So understanding that the pattern in photons is different than the pattern in electrons. There are specific, real differences. and mostly in terms of the photon pattern isn't as gradual. It's supposed to be the on and off aren't really on. It doesn't gradually get light and gradually get dark as the mathematics predicts, and instead they're kind of bar-like. A little bit of fuzz around the bars, but pretty much on and off. Where in electrons you do get a very gradual pattern. Again, these differences are likely very significant, and yet no one pays any attention. Now, I'm not even sure about the electron pattern, whether it creates the double pattern. So another thing conventional physics just avoids the subject of is the fact that the double slit pattern has two patterns in it, overlapping. Not even overlapping, that's the wrong word to use. Combined. They have no wave theory that explains the existence of those two patterns, because it doesn't happen in the other experiments. So there's lots of stuff to understand, and lots of detail in the physics of these experiments, and yet they'll just waste your time talking about whether the photons have radar, or whether the photons create new universes, or whether the photons can do probability math. Instead of talking about the fact that the photons are, as we understand them from every other experiment, experiments, all the other experiments sort of point to photons being really dumb and having no features whatsoever, very few features. They have a frequency, and they have a constant velocity, and they have a definite quantizable momentum. That's the whole point of saying quantum mechanics, is because photons basically said to you, there's clump, and it's always the same clump. They're all blueberries. Well, it's a bad example, because blueberries have all kinds of size difference. But they're all the same thing. Whatever. There's probably an example. BBs. 38 caliber bullets. They're all the same thing. And you shoot them at the same velocity, and you shoot them pretty much in a straight line. And so I'm just saying these are the details that are just overlooked because their eye is on some sort of way over there prize of figuring out what kind of wooey, crazy, wacky explanation. Who can come up with the wackiest explanation explaining why this simple thing happens where photons don't go in a straight line. So I'll provide you reasonable causes for the effect, and just to contrast and say that, again, this is supposed to be the scientific method. It's supposed to be careful. Physics shouldn't be based on jumping evidence and presumptions and rushing to judgment. That's not what the professionals are supposed to be doing. Professionals don't rush to judgment. Scientists of the past sort of learned all those lessons that if you jump to conclusions, you're probably jumping off a cliff. So you got to be careful. We all make the human mistake of seeing it seems like, and it really, really seems like, and sometimes it really, 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 really seems like, and you have this notion that it should be and it could be, and that's all a human frailty. But again, if you're going to be something called a scientist, you're supposed to recognize that you really do have to have your case put together. You gotta do the work. It's like lawyers in a trial. You don't just show up and wing it. You spend time understanding the evidence and understanding how to present it. And if you're decent and honorable, which lawyers aren't, so they're always a bad analogy, your objective is the truth, not something else. You're not trying to get somebody off. You're trying to get it right. Provide the opportunity for the jurors, the judges, to make the right decision, to get the correct answer. And science doesn't do that anymore. I would argue the evidence is overwhelming that they don't do that anymore. So I can tell you they've cited experiments that have never been done as part of their evidence. That's just one of the first rules of fair trying, is you don't fake evidence. You don't claim you have what you don't have, So there's a list over there, of just talking points about how it's all subject to their evidence is incredibly weak, and when barely scratched at, you can understand that they're jumping. The case of when they do this experiment with radio waves or microwaves, they will use gimmicks to make it possible to better see it. And those gimmicks of putting an audio signal on the signal break the observability of the experiment, in the sense you're not detecting the real carrier. You're not detecting whether or not there's actual signal in a place. You're just detecting whether you can receive the signal, tune it in. There's other explanations. In the case of those experiments, jamming would have exactly the same mathematical consequence, and would be mathematically the same geometry. And it's a perfectly valid explanation for why you don't receive the signal. There's no flaws in it. It's just as good an explanation, and it's never even talked about as a possibility for explaining why that experiment works. I can get into interferometers, because this is more wave interference stuff where we have no explanation of what would happen to a single photon in an interferometer, what path it would take. None of this. There's just absolutely no detailed analysis of the experiments themselves, and no connection made at all between the photon and the facts of, like, say, we are passing it by a material substance, and what's the consequence of passing a photon by a material substance? What's the material substance actually look like on the scale of the photon? So they just show you two slits, or they show you a single impediment. They don't explain that this surface isn't flat. It's not some sort of smooth surface that photons, all they see is a silver wall. That's not what the photon is seeing. The photon is seeing atoms and electrons, and it's seeing a mixture, an environment where two different mediums are mixing, two different substances, one full of gas and one full of solid. And these two substances, we already know that these layers where they're mixing are always messy, and have a lot of nuance, a lot of character. We know that in transparent substances, these things will bend light, these surfaces. So you can get into the whole argument about, well, where does the light bend when it goes through a prism? Well, it bends at the surface, and you can deduce that if you just examine the evidence. And so the surface is a highly reactive place where weird things can happen. There's no conversation in the two-slit analysis dealing with what the surfaces are doing at all. It's like they don't have any surface character anymore. Everything we learned about surfaces is ignored, and we just pretend, it's brick walls everywhere, when there's no such thing as a brick wall in the subatomic, on the atomic scale. There's no brick walls on the atomic scale. There's no flat surfaces anywhere. So, like I said, you don't even have to scratch at this very hard to know if this is what they call their nail in the coffin evidence. This is their proof that something's wrong. Houston, we have a problem. This isn't the way it's supposed to go. This isn't the way science is supposed to work. And it's not working, in my opinion. And this is one of the reasons. You can just see it overtly. In this important case, the whole foundations of quantum mechanics are based on it. And it's just fundamentally and grotesquely flawed. The analysis is so trivial and so incomplete. So I guess I'll do some drawing and just emphasize these points in summation of some way. And I've made videos before on these subjects pointing out some of the stuff, and I didn't know these details 5 years ago, and because there is no conversation about any of this stuff. You don't learn it in school. They focus your attention on one thing, and they just ignore all the other stuff, and you got to go find it yourself. You have to think about it, and you have to find, well, what if, and, well, what about, what are surfaces? You have to ask yourself the question, because they won't encourage you to ask it while you're analyzing the experiment. They will never encourage you to say, what are surfaces? when they're analyzing the double slit experiment. And yet the experiment, it's fundamental to the experiment what a surface is. What's a free electron even? You know, it's sort of a different, a somewhat separate subject, but we know that photons and electrons, you know, the original quantum mechanics was quantum electrodynamics, and it really just had to do with the fact that the quantum, called the photon or electromagnetic radiation, had it always interacted with electrons, and that phenomenon ran our world, so to speak, and yet all that conversation's gone when you talk about photons. No, there's no conversation about what might be, what electrons are doing while this pattern is happening. And if you understand electrons, you understand that they're negatively charged. There's no such thing as a peaceful place of the universe for an electron. There's always some sort of imbalance in a field if there's any kind of matter near it. So there's no such thing as a free electron. Electrons will congregate where protons are. They're going to hang around where the girls are, you know, kind of thing. And it's just a fact. You're not going to find them off somewhere else doing something else. Except for the anti ones. Yeah, which is just more gibberish, made up nonsense. Anyway, so yeah, I guess I'll do some drawing just to point out some of the illustrate some of the points made and such. Alright, I'm back pretty much. So the first piece of analysis is to understand that this experiment is done with either a broad light source, a whole bunch of photons sent through, or single photons. And single photons, sort of understood as a ray, a straight line that goes from point A to point B, is what we understand photons, or what we see photons do, is they come from a source and they travel a straight line and land in another place, in a very tiny place. So they come from a tiny place, they land in a tiny location, and that line doesn't look very straight, which is interesting. Let's see if I can straighten that line. Oh, not without making that all crooked. Well, the hell with that. Alright, I'll just remember that what's straight to me isn't straight to you. You know, it's just part of life, I guess. Anyway, so it's single photons, and yet every time they draw the two-slit experiment, they always put these waves coming in, you know, and somehow the waves are breaking like little water waves into these little lumps, and these little lumps are crossing over each other and creating this pattern of directions. And let's understand also that these directions are just multiples of the same angle. So if the difference between N1 and N2 is 3 degrees, just to make it simple, then this would be 6 degrees of deflection, and this would be 9 degrees of the deflection, and that's what the pattern produces. And so there's nothing, it's very straight geometry, there's nothing wavy in the outcome. The outcome is just a, you know, times 2, you know, times 3. Very uncomplicated in terms of what the end result is. There was another point I wanted to make relevant to that, and I just lost it, unfortunately. Yeah. Alright, so clean this up a little. So if it went done with single photons, the expectation that the single photon is, you know, doing some sort of trick where it's going to all these locations. Well, their math and their theory says basically that there's a probability, by Feynman's reasoning. See, Feynman explicitly said he doesn't really believe in this wave theory. He didn't say those words, but he said, he explicitly implied, he clearly didn't believe photons were waves. So he clearly didn't believe they split in two and create wave patterns. He believed there was a probability that they were going to end up in a location, and that was just a fact, and that the randomness of that location, the probability, was essentially a fundamental character of the universe, and he didn't bother with why. He just said that's the way it is, but that these are corpuscles. Photons are little things that land in discrete locations, and they aren't some other thing in some secret life they have at night. They don't have some secret life where they come in as a wave and break into things and have radar and do all this kind of stuff. So he's one of the founding fathers of quantum mechanics, and they kind of just whitewash over the detail that Feynman didn't really believe any of their fundamental theory about what's going on here. Now their math says there is a probability, okay, some probability of the photon going almost, 179 degrees, 89 degrees from center. So there's a real, 89.9999999. There's some real probability. Now another experiment they've never even bothered to test by putting a photographic plate here. So they've done photographic plates here to get their little patterns, but what they've never done is put a photographic plate here and see, well, can we actually capture the photons that go here? It would be a piece of information that would give you understanding of what's happening, and it would sort of give you the understanding if you did the experiment and found that, well, no, I waited 1 year and no photon ever went here. It just never happens. Then that would tell you that there's a flaw in this wave theory, that maybe it's not what we think it is, because it should be here, and it should be here, and it should be here. It should be in all these weird locations. There should be an amount of light that does do that. Now, so these are all just facts. Like I said, I'm an amateur here, showing up to say, okay, this is all analysis they never talk about. When they're going to talk about this fundamental property, they don't sit there and think about any of these details about how you might be able to test the veracity of this theory they have. So what I'll point out is, when I did a little thinking about what a possible counter theory might look like, what I came up with, and it seems a lot more rational than what they have. So I would argue that we already know that surfaces, okay, are complicated, and that if I have a transparent surface, a material, glass or something, and we have air, that we have a refractive index between these two substances that happens at this surface and at this surface, and that there's a certain percentage of the light, a certain percentage of the time, a single photon will either reflect off this surface, technically, if you're going up and down, it would reflect back, of course, or go through the surface. And if it goes through the first surface, it'll be deflected. It won't go through the surface in a straight line. It'll go through the surface off the straight line. So it should have gone this way, it'll go this way. And then when it comes back out again, because it's going the inverse through the thick medium to the light medium, it'll bend the other way again, and it'll re-parallel with its original trajectory. So it'll have its angle restored. So we know this happens. This, is just a fact that this happens at a surface. Okay, it doesn't happen in the transparency. Okay, it happens at the surface. So logically, you could deduce, well, it really doesn't matter if it's transparent. I mean, it matters in the sense that you won't see it go through the material, so you won't see it come back out. It matters in that sense if it's not transparent, but the surface is really indicating whether it's going to get absorbed or whether it's going to get reflected. And you can change that reflectivity just as you can with glass. By polishing it, you can go from 16% light reflecting to 0% light reflecting, depending on how thick this glass is. So I make it a little bit thinner, it'll go to 0. I go a little thinner, polish it, I can get back to 16. So it goes from 0 to 4 to 8, to maybe 12 to 16% chance of reflection. And obviously something like a metal surface, you could increase that to maybe 100% reflection. Who knows? I don't know the exact maximum you can get out of a surface in terms of its reflectivity. But the key point is this is a surface phenomenon. So it's happening even with an opaque material. You're still getting the same phenomenon of absorption and reflection. You just can't see the absorption because it doesn't travel through the medium consistently, so it doesn't get to the other surface, and it doesn't get emitted out of the other surface, so you can't see it. But that's all that's happening. That's the only difference. So what we're talking about is what happens when you excite a surface. That is, you force it to either release energy or it has to absorb energy. So let's analyze. Just a simple view of what's happening in the two-slit experiment or the single-slit experiment is that you do have these two surfaces, and they always draw them as these nice flat things. But again, we know that atoms are what make up that surface, and the atom has protons and electrons, and it's just not as simple as a straight line. And as I'm arguing, we know that if there's an electron out here, he's going to see this proton. Now he's going to see it weakly, but he's going to see it. He's going to smell it. He's going to be in a neutral position, except this proton. So there's another proton way the hell over here, right? That one's not going to have as much influence, and so he's going to drift this way. And the closer he gets, the stronger the pressure will be to move in that direction, because the more energy they'll be leaving the proton and the electron, blah blah blah, if they're not in another subject, and it will move, and it'll find a location where it doesn't like this electron, so it has to find a place maybe here where it can still get to the proton, it can still feel the love and the hate, and it'll sit in this balance between I love her and I hate him, and it'll just stay somewhere in here, and it might jiggle around a bit, and that's what free electrons will end up doing. And we know that the two-slit experiment is most of the time done in air, so we know that air, is made up of atoms that have electrons on them, and so they're all going to line up maybe too. When they're in between this surface, they're going to be feeling the density of the there's a higher density of protons here and a higher density of protons here than there is in here. This stuff is solid mass. These are heavy atoms. These are light atoms. So we know that these atoms are probably going to range up a little bit too. Their electrons are going to be locking in tension. I love her, I hate him. They're going to be doing all that stuff. Sorry about the glare. Well, anyway, so I don't want to get into a whole bunch of theory about electrons, but I mean, clearly the surface, you have to start talking. When you're talking about a surface, you're talking about something that has a nuclear properties, that has atomic properties, that has real properties. So my simple argument, I didn't think of it until, that's the thing. They don't encourage you to think about these things. But obviously, again, I'm saying that we kind of know, we can kind of say with some authority that surfaces are complex. So, we have this transition medium. We know this refraction thing happens. So, what if, in this double slit or single slit experiment, you can kind of realize what you're really doing is instead of sending the photon this way, you're sending the photon this way by the slit. Well, what would be the consequence of plowing photons through that medium, through that area where these two things are mixing? Where little bits of oxygen are going into this and little bits of glass are popping out of this, and there's all kinds of mixing going on, and that's likely the result. That's likely what's causing this change in angle, is that the photon is hitting an electron that is in a confused state. He's trapped between love and hate. He's not really part of this atom or part of that atom. It's in kind of a ambiguous state where he's trapped between Jane and Jill, and Bob, and he's trying to balance that tension. And if the photon hit that electron, what would that electron do in that tension? It would move this way, or towards Jane, or would it go towards Jill, or would it, push into Bob a little bit and then say, I gotta get the hell out of there. So that's the idea, is that we're pushing the light in the slit experiments. What you're doing, I mean, it's a simple mathematical thing, right? As you narrow these two surfaces, as you bring the surfaces closer together, what are you doing? You're increasing the odds of casting light right next to these surfaces, pushing a higher percentage of the light. As you move the surfaces together, a higher percentage of the photons will incidentally hit near surfaces, will travel near the surface. So you're increasing the likelihood of an interaction with electrons, quite obviously. The simple answer is that's what you're doing. You're increasing the likelihood of an interaction with an electron when you're moving something closer and closer to a surface. That's not a bold accusation or statement. And the electrons are what's causing the refraction, the deflection, based on the pressure they're under and how many of them you might hit. So the simple answer might be that each time you hit an electron, each time a photon hits an electron, it gives the electron momentum. So this is almost a Feynman diagram. The photon hits the electron, right? Then the electron moves. So this whole thing moves to a new location here. The new location for the electron, again, Bob is right over here, you know, and so that electron is going to feel the repulsive forces, the reflective forces between Bob and this guy, and so then he's going to move back, and when he moves back, he's going to eject the photon in a new direction. So the only thing we have to include into this theory is this: what if Bob isn't straight ahead? What if Bob is over here? Then this electron's going to move this way when it moves. So when this happens, the electron goes this way instead. Alright. And then when it feels the pressure of some other thing over here and gets pushed back, it releases the photon from a different location, moving in a different direction. I should just redraw that. So when it moves back this way to attempt to get back to normal, it will release the photon in that direction. So that's where you get the angles from. Is the tension that the electrons are all in, and they will move a little distance, encounter a counter force, because if they could move a little distance, they would have moved it on their own. It's the photon that's the force. This is a force, photons, and you inject a force into this electron, and then this electron will encounter force as a rejection of this movement, because this is the balanced place. The electron's already in a balanced location. You're going to imbalance it with this momentum. It's going to react, and then there's going to be a reaction from the field basically saying we hate you or we love you or whatever, and it's going to push it back, and that's what's releasing the photon. So all you have to really think about it is there are electrons near the surface, and you're sending a photon through. Well, let's put these in random places, sort of random. You send a photon through, and there's a certain probability of it getting, each time it hits an electron, you could say it could go 3 degrees this way, or it could go 3 degrees this way. Well, if it goes 3 degrees this way, it hits this electron, then that electron could send it 3 more degrees that way, or it could send it 3 degrees this way, which ended up put back in a straight line. So you can see that, well, if it goes this path, and then there could be another one here, and it hits that one, and it could go this way or this way, but it goes this way. Well, now we've got 3, 6, 9. We've got 9 degrees of reflection, and it just really has to do with how many electrons you hit. You hit more electrons, you deflect more. Now, this would have no probability, okay? There'd be no probability in the slit experiments for a photon to go this way, because you'd have to hit like 7 million electrons to get deflected that much. So there wouldn't be any probability of light here. This would be the only range that would be realistically probable. Whatever, 27 degrees might be the maximum that you have. That, you know, it'd take a year to get one that lands 27 degrees. But you have a finite number of electrons, so there's only so many that you can actually hit and actually be deflected. So another way you could do this experiment is to make the surfaces out of thicker and thicker material, and see if that increases the possibility of these more elaborate deflections. I guess you can't see that this was an opening there. But anyway. So yeah, so the simple way of mechanically understanding how it can happen is you have to take into consideration the surfaces. You have to consider that this area, okay, is going to be different than this area in a charged circumstance. Again, these are all charged circumstances. So we know that if I just have a surface and there's nothing very close to it, you can know by just the odds of averages is that this surface will be there'll be an electron bias. And so if I start to bring two, so this is the Kashmir kind of thing. So if I bring two surfaces together, we know they can't be electron facing electron. That is, the atoms can't be the protons in the back and the atoms on the outside. Both surfaces can't stay that way. So we know the closer I bring these things together, it's material objects, that something's got to change. One of these atoms will have to go positive and one will have to go negative. It's like they're on a desert island, you know, one's got to be one's got to become a girl and one's got to be the boy kind of thing, however you want to analogize it, but it will not work if they both stay negative. They both stay electron on the surface. So one of them's going to have to switch to being, you know, proton heavy on the surface, and one will have to be, and one can stay electron heavy on the surface. And this will make them compatible. Okay, so, and that's essentially the fact that these plates will automatically charge positive and negative as you bring them together, because one will have to do that. They'll have to change, and as they change, they'll change more and more. So as this atom flips, then the atom next to it will also have to flip. They'll all have to flip to meet the fact that this is becoming a stronger and stronger charge as this one becomes a, you know, so as they decide not to go 50-50 and one has to go, you know, 40-60 and then they'll go 60-40, it just, the effect gets stronger and stronger. So we know this is a complex thing, surfaces, and we're putting surfaces right next to each other, creating small slits, and there's every reason to understand that when we're doing that, we're messing up the electrons that would be in this medium in between. So the air, you could think of it as a dielectric, in the sense that the air, just like water or something else, is likewise going to end up, the atoms in the air are going to end up lining up with this charge. So this charge is positive and negative, and the air is going to go negative and positive. You know, this little air layer, generally speaking, is also going to change. So we're changing the arrangement of the electrons. And so there's every reason to understand that photons interact with electrons. The electrons move, and from the new location they emit a photon. That's basic quantum mechanics. You can't dispute, I'm not disputing that quantum electrodynamic effect, that Feynman diagram. This is a real thing that happens in physics. Photons impose acceleration on electrons. Electron acceleration diminishes with distance, and as soon as it changes, that is, it stops moving, it has to eject energy to do that in the same general direction that it came in. The same angular momentum, if you want to argue that. And that's the way the system works. If you hit it with yin somewhere, okay, that extra amount of yin has to be given back. I don't know how you want to say it. If this is pennies and this way is nickels, or this is heads and this is tails on a coin, when you have an extra bit of tail somewhere, it's got to come back. It's got to go back, okay, to equalize the net balance. Always has to be the same. There's a conservation of heads and tails, so you can kind of know that if a bunch of tails are going one way, there has to be a bunch of heads going the other way. Alright, I think that covers quite a bit of it. I'll take a bit of a pause, and maybe we'll just go over some of the text and call it a video. Alright, back. Okay, so my first argument is just sort of this obvious argument that this never was about slits. Newton did the single impediment experiment. It's not a slit experiment, but it's obviously the same exact phenomenon. Something happens to the photons. Their direction is changed. So it always should have been referred to as the direction change experiment or something else. I mean, I think it should be called the obvious thing, which is the surface experiments. Single surfaces actually do this also, just hard to see it in single surfaces because you have nothing to obscure the light. You know, the light that doesn't get affected, that doesn't travel next to the surface. But it's there to be seen with precise enough equipment. People have done single surface experiments and gotten the same kind of deflection pattern. So part of the problem with this is clearly just sort of a dishonest description. I mean, the description of the experiment isn't even accurate. It doesn't really get to the nuclear physics. It doesn't get to the atomic physics. By calling it the two-slit or the single-slit or the multi-slit, again, it just distracts your brain from what you should be understanding, which is this is about photons traveling near surfaces. That's what narrowing the slits do. It just creates a higher likelihood that you're going to hit the photon will end up going near a surface. And they've gotten away from all of this stuff where the photon actually goes because they've pretended that photons don't have a location, that they're, even when they give them ray-like qualities, they say, oh, it's somewhere in here. It's going that way towards you, but it's doing it in this kind of way. They're not sure where it's going towards you, how it's getting towards you. And they've used all this stuff to create an ambiguity when I think it can be logically understood. There's no ambiguity for the photon. It knows where it is, and it knows where it's going in the sense that it's got a pure vector of momentum, and there's no doubt about its momentum at any point. And these are just word games. And the big word game is to avoid talking about what these really are, which is experiments where you pass light in the proximity of surfaces. They're surface experiments. The more evidence is the inconsistency. The theory doesn't work for single slits, double slits, multi-slits. They use Huygens to explain why the single slit creates two waves. They use a simple, they just cheat. Again, they just decide, well, everything cancels out if I create an artificial middle. Okay, I can create two waves and everything will cancel out except this one and this one. You know, and I can make two waves. So, you know, they use a gimmick to create two waves when there's a single slit. And yet when there's a double slit, there's only two waves. So in single slit, somehow this creates two photons, two waves. And this one would create two waves if these were separated. But somehow when I put them next to each other, somehow now they only create one wave. No consistency at all. And then in the multi-slits experiments, you find out that, well, actually, exactly what image data goes right through here. Like, say if I had an image of Daffy Duck here, the truth is that whatever part of Daffy Duck goes through here, and whatever part goes through here, and whatever part goes here, it's going to be transmitted to each location from each place. And so, in the end, you'll get a picture of Daffy Duck out here. Even though it got bisected by these impediments, the actual image of what went through will ghost the location, which should be kind of a giveaway that this can't be wave interference because it matters where exactly the photon went through. It's a specific place, and it will, you know, there'll be a probability that the image for each individual photon will come to the slit and say, I'll either go here, 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 or here. I won't go to any of those places in between. And each piece is saying that. And it's only you can only make that make sense by recognizing that the photon, where the photon went in, is important. It's not going to get the same effect if it goes in here or if it goes in here, because then you'd end up messing up the image. So you got reasons to know wave interference doesn't work. There's things in the way of that theory being correct, and they just ignore those things. I didn't really get into the fact that there's two patterns in the double slit. Again, not explained by wave theory. I don't necessarily have an explanation either, but I think it just has something to do with the fact that in the double slit you have a compound electrical field. You know, plus, minus, you know, and that's what's creating the complex, the two effects. The pressures are reversed in the two circumstances. This one has pressure going this way, and this one has pressure going that way. Anyway, all right. So another fact is there's not a proper gradient from light to dark. So they always talk about how this is the most predictive math in the history of mankind. It's perfect. It always gets the right answer. Well, it doesn't get the right answer in photons. Visible photons don't create the right pattern, what the math says it should. And again, they haven't even tested for the, you know, their infinite probabilities. Essentially, they have an infinite probability of the thing traveling the, you know, the 179.9999 for infinity angle, and they've never even tested for that angle. So, I mean, these glaring insufficiencies. This evidence is not good. There's every indication that it's fake, and it isn't what you think it is. It's kind of like an indication that the gun was rusted to an anvil, and nobody could pick it up and shoot it. You know, that kind of thing. There's reasons to understand it can't be the way they say it happened, because the gun is rusted to the anvil. It can't, you know, it couldn't have, you know. Anyway, there's counter evidence that says the evidence isn't what you're describing. It couldn't have happened that way. There was no wheels, there was no tires on the car, and so they couldn't use it as the getaway car because there was no tires on that car. Anyway, the difference between electron and photon pattern, so there's just no, I didn't go into a whole thing about it, but obviously what I'm arguing is that when you're doing the experiment with photons, you're hitting a sort of a big thing with a little thing. A photon hits the electron, moves it a little, new photons emitted. When you're doing the experiment with electrons, you're hitting an electron with an electron. Now, electrons don't hit each other because they're charged. They hate each other, so they deflect off of each other. You know, they deflect off each other's field, in the sense that they deflect off the reflections. It's like they're mirror surfaces, and they're reflecting whatever one throws at the other. He throws a rock, the rock bounces back and forth between them forever, because they're reflective to rocks. So they bounce off each other, they don't hit each other. And that's why the electron pattern is very smooth and gradated. Is because the electrons are bouncing. They're not going at as precise an angle. The precision of the angle fluctuates based on whether they hit each other hard or they hit each other soft. Alright. And then the experiment's not done. I mean, it's just a glaring cheat performed by this desperate effort to justify this wave theory as to describe detector experiments that were never done, and describe them as if they were done, and the results concurred with their theory, when they haven't done the experiments, and there's every reason to believe that if they did do the experiments, it wouldn't validate their theory. Because there's still a mechanism, and the mechanism is going to create some sort of consequential pattern. It will not make everything just magically go away. I've made refraction go away. You won't make the refraction go away, you'll just add noise to it. But they haven't even done these experiments. The detection process will make a fog that will make your results less visible. But the fog won't destroy what was going on. The fog just makes it harder to see. Divergence of the beam. So this is just an argument about the fact that we can't aim a photon. If we could aim photons, then we could eliminate all. Big part of their theory is that we can't somehow know where the photon is, and if we attempt to detect a photon, they make themselves invisible, or they bounce around more, or they do something to prevent us from knowing where they are. Some kind, it just gets that wacky. But we know this is just a liability of the fact that we can't aim. If we had aimed photons very well, then we just aim them through the slit. We'll know what slit they went through. This is another experiment they haven't tried to do. I think they could actually do it now. I think they have the technology to do it now, and they just don't do it. And I don't have a good explanation for that, except that they have no imagination and they're fanatically Muslim, and they won't even read the Christian Bible. They won't even think about a counter argument. All right, horizontally and vertically flipped. So again, this is an image argument, but the facts are that if you put defects in the slit, you'll see the defect in the image, okay, and it will be reversed. So now we're back to this being an optical effect, and optics are about photons hitting electrons. This has nothing to do with magic bending. This has nothing to do with photons waving and bending. This just has to do with the fact that photons hit electrons, and when they do, electrons don't travel necessarily straight lines, and you'll get a new vector of direction out of the photon. Okay, sine theta in the mathematics, again, is just an angle. It's angle math, so they call it the wave equation when it's really just an angle equation. These are just ways of manipulating language, manipulating understanding. It's critically important whether you call it surface experiments or slit experiments. It's critically important whether you call it a wave equation or you call it an angle equation. These words matter in terms of how they get your brain thinking, and so it's all just part of a, frankly, it's propaganda. It's use dirty words to describe things, compare them to things that they shouldn't be compared to keep people's brains thinking in a direction, and it's just wrong. All right, single surface diffraction, so that might be referencing just the fact that this is about surfaces, and surfaces bend light, and if you go through the surface this way, or you come through the surface this way, go through the surface this way, or you go through the surface this way, fact is you're still going through the surface. The single surface to force, I've already kind of went over the differences. Looks like wave interference, but isn't. And the fact is it does, but it only looks like it in the double slit. In the single slit, you got a real problem because there's no two waves with a single photon. And in the multi-slit, as pointed out, they're basically images going to the different locations, and in images are not what interference creates. Alright, with visible light, the effect is caused by electron deflection. We already went over that. In the microwave radio experiments, clearly jamming math is exactly the same as wave interference math. The geometry is exactly the same. So it's a perfectly rational description versus their irrational one. A simple explanation versus their very complex explanation. And again, in the radar experiment, they don't even have they don't have two slits. They don't even have something to cause the wave to break into two waves. There's not even a mechanism for that because there's two sources. And the theory is that somehow two sources are creating wave functions, when if we have no explanation for why a source would create a wave function instead of an actual photon. So somehow the sources are already creating wave functions. That is, somehow the photons coming out of the sources is already in a form of a wave function, which just doesn't make any sense, because we know we can't shoot two laser beams into each other and cause them to interfere with each other. We can't make laser beams interfere. We can't make photon interfere with photon. So why in the radar experiment are the photons interfering? How are they doing it? They're not in the form. They're not in the proper form. They haven't gone through the proper instrument to cause the phenomenon of their transition from solid object or solid thing into amorphous wavy thing. So there's just no consistency. There's no consistency in the theory. You need the slits to break the wave, to create the wave functions. Why in the radar experiment do you not need the slits? It's like me doing the double slit experiment. Just eliminate the slits and just shoot two laser beams into each other. I can't do the experiment that way. It won't work. Why is it working in radar? They have zero explanation. I can't put two light bulbs and make them interfere with each other and create an interference pattern. Can't do it. So why does it work with radar? Same stuff, photons. How's it possible? So anyway, no, I think I've done my job. If you're a rational, reasonable person, you would at least concede this needs more work. They should have done more work. There needs to be more conversation about what this is exactly is happening here. If you're going to use this as a foundation for your theory, you've really got to tighten it up because it's got too many loose ends. It's way too unclear that you have evidence sufficient to convict and call the thing a wave. There's just not nearly enough evidence. And if you're not able to say that, I'm saying you're just plainly incredibly biased. You have a prejudice. You're a propagandist. You're a fanatic. You have motives other than seeking the truth. Because if you're an honest person, you have to understand that the facts are how you get to the truth, and the facts create, have contradictions in them. And you have to fix those. You have to fix those. You can't just pretend they don't exist. They exist and they have to be fixed before you go around claiming you have the answer. And underlying all of that, I would argue to you, I can use this other theory and make it consistent with magnetism and gravity and everything else that happens in physics. I can use this as a key to unification. Your theory doesn't unify anything. Your wave nonsense is completely inconsistent with bent space and all the other theories. You have no hope, frankly, no hope at all of creating a theory that creates a simple mechanism describing function. Yours is trapped in a ton of layers of complexity. Complex functions, the simplest things. Every experiment indicates simple thing. Point A, point B, straight line. And you're turning it all upside down because 1% of the experiments indicate there's some reason I have to turn everything upside down. I have to turn it into an invisible man. I have to make it a shapeshifter. I have to make it into some sort of alien. I mean, we all have our moments, where we're not our consistent personality. But they're just moments, and we know they happen for a reason. And the simple argument is the reason is obvious in the two-slit experiment or the single-slit or any of these slit experiments. The obvious reason is you're forcing the photon to interact with matter. And that has a consequence. Photons don't have all of these capacities. Matter is the complex thing. Matter's imposing the pattern, not the photon. The matter's imposing it. Like I said, all I can do is make rational, reasonable arguments, and you'll either be reasonable or you'll be an asshole. So, make your decision. You won't have a choice to be the asshole. You'll just make a bad decision. And such.